Greetings to all. In today's session, we are going to discuss about the chemistry which is related with the international platform where you are aspiring for any entrance examination or competitive exams on the international floor, India level, JEE advanced and JEE mains examination to enter into technical stream, NEET chemistry for the medical entrance examination, Telangana EAMCET and Andhra Pradesh EAMCET examination. In addition to all these, if you are aspiring for any competitive exam, for all these, the kind of discussion will be very much helpful. Let's enter into our today's session. Here, question number 1 is provided. Rules to write the IUPAC name of organic compounds in the perfect way. This is the compound given. The question 1 will be related with the organic chemistry, where you can find the carbon chain. Each corner denotes a carbon. And there is the way to give the answer for this one. As per IUPAC, the nomenclature is provided over here. And there is a possibility to give the numbering 1, 2, 3, 4, 5, or else 1, 2, 3, 4, 5 like this. Okay, the way you have to give the numbering in accordance with the given functional groups. Here, if you see methyl and aldehyde, obviously aldehyde will get the higher priority over methyl, being both are of 5 carbon chains, and we have to go for the numbering in this direction only. Carbon of carboxylic acid will get the number 1. Second, third, fourth, and fifth will be accorded for the aldehyde over here. And this is the correct order of numbering over here. And this will become a parent chain over here. And here at the third carbon, you can find the fourth and the 1 and 2 carbon, so that ethyl substitution will be there. So for this kind of organic compound, numbering will be started from this 1, 2, 3. At third carbon here, ethyl will be there. We can say 3 ethyl. At fifth carbon, aldehyde is there. Aldehyde, if present at any other terminal, we have to mention it as oxo, right? And being it is the carboxylic acid, general IUPAC nomenclature will be alkanoic acid. Hence, we can say, being it is a 5 carbon chain, we have to say pentanoic acid. So entire name will be, at third carbon we have ethyl, at fifth carbon we have oxo and pentanoic acid. 3-ethyl 5-oxo-pentanoic acid is the IUPAC name of the given organic compound. Let's move on to question number 2. When nickel Cl2 6H2O is combined with the silver nitrate, 2 moles of silver chloride precipitated per mole of the coordination molecule. Write the complex structure formula and IUPAC name. So these many options are provided. Within the problem number 2, they are asking for what is the structural formula, what is the IUPAC naming of the compound. For that, so if you carefully observe this one, the reagent is silver nitrate. Silver nitrate is the reagent to identify number of free halide ions present outer the sphere of the coordination complex. So it is indicating that 2 moles of silver chloride got precipitated. It's obvious to know 2 free chlorides will be there within the compound. So outside the sphere, 2 chlorides if indicated, the complex coordination sphere will be indicated as nickel H2O taken 6Cl2. Being it is the compound of octahedral, IUPAC naming will be hexaquonickel chloride. It will be pronounced as hexaquonickel chloride, and in specific we can say hexaquonickel 2 chloride, right? This is the way to give the IUPAC naming. Let's go with what will be the geometry, how to write its coordination sphere. And explanation is provided why silver nitrate is giving 2 moles of silver chloride. So because 2 chloride ions are free, which are called primary valency, and whenever they ionized outer the sphere, got ionized, inner the sphere got unionized. So 2 moles of silver chloride generated by 2 chloride ions. Hence, we can write the ionized form of the complex as nickel hexaquo plus 2 and 2Cl minus. So this is the way we can answer. So let's see the coordination sphere of hexaquo nickel 2 chloride complex. Central nickel surrounded with the set of 6 aqua ligands over here, and it is in the sphere of coordination, and chlorides are there in the outer sphere. Whenever it is treated with 2 moles of silver nitrate, the chloride ions are easily replaced with the nitrates, and silver able to precipitate chloride as a silver chloride, which is the milky white precipitate, and its coordination sphere is indicated. Nickel H2O taken 6 Cl2, right? So this is the way we can answer the question number 2. For question number 2, option number A will be the correct answer. Let's move on to question number 3. The right option for the mass of carbon dioxide produced by heating of 20 grams of 20% pure limestone, whose atomic number of calcium is given as 40, calcium carbonate upon decomposition at 1200 Kelvin temperature, giving calcium oxide and carbon dioxide. The question is, how much carbon dioxide will be generated? Mass of carbon dioxide will be 1.76 grams. This will be the correct answer. Let's see how to solve this problem. In order to get this, the given data is atomic mass of calcium is 40. Calcium carbonate decomposition at 1200 Kelvin is calcium oxide and carbon dioxide, right? Weight of impure limestone is given as 20 grams. 20 grams of limestone contains 20% of purity. Means in 20 grams, if 20 grams purely limestone, we can say 100%. But in the 20 grams, only 20% is highly pure calcium carbonate, else will be another additives will be there. So if you want to get the weight of compound, so here we can write weight of the pure limestone is equal to, so weight of the limestone given by gram molecular weight into percentage purity of the compound. 20 multiplied with 20, we will get 400. 400 over 100, the answer will be 4 grams. 4 grams weight of limestone will be there. Number of moles of calcium carbonate is given by, number of moles always given by weight by gram molecular weight. 4 by 100. 4 by 100 is given by 0.04. Fine. So here decomposition of calcium carbonate, we have two products. One is calcium oxide, another carbon dioxide. So number of moles of calcium carbonate is 0.04. Equal number of moles of carbon dioxide will be originated over here. That's why N is equal to 0.04 is recorded for carbon dioxide as well. So that number of moles of carbon dioxide is 0.04. It is obvious to convert into weight of carbon dioxide. Weight is equal to number of moles into molecular weight of carbon dioxide. Number of moles is 0.04. Molecular weight is 44. So that weight of carbon dioxide is equal to 1.76 grams. This is the way we can answer. For question number 3, option number A will be the correct answer. Let's move on to question number 4. It is the part of inorganic chemistry where the kind of reduction reactions are provided and their enthalpy values, heat of formation enthalpy values are provided over here. We have to get delta H value of the final product of this equation. The following two reactions are known. Ferric oxide and ferrous oxide got reacted with carbon monoxide. Both are giving iron in addition to the carbon dioxide. And both are exothermic reactions with the negative enthalpy values in kilojoules. Fine. So in accordance with the given data, we have to retrieve delta H of the product given, that is ferric oxide upon treating with carbon monoxide. Ferrous oxide and carbon dioxide is only enthalpy is needed to be calculated. In order to get the relation, so we have to go for the sequential solving of the problem. The correct answer will be option number C, plus 6.2 kilojoules. Let's see how can we solve this problem. Right. So whenever Fe2O3, 3 carbon monoxide is given, 2 Fe plus 3 CO2 will be generated along with the release of 26.8 kilojoules of energy. Ferrous oxide upon treating with carbon monoxide, iron plus carbon dioxide will be generated minus 16.5 kilojoules. So if you take this second equation and multiplied with the numeral 2, if second equation multiplied with 2 FeO plus 2 CO, 2 Fe, 2 CO2, entire terms will become 2. 2 FeO, 2 CO, 2 Fe plus 2 CO2 will be generated, right? So for this reaction, we have to multiply delta H value also with 2. So that 16.5 will become minus 33 kilojoules, right? This is the equation number 3. This equation number 3 is equation 3 is subtracted from 1. So 3 we are having Fe2O3, 2 FeO will be there. So if we are putting minus over minus 2 FeO, so this minus FeO will become right hand side plus value. Left side, if minus is there, we can shift it to right hand side so that it will become plus value, right? Fe2O3 remains as such, Fe2O3, and minus FeO can be taken right hand side so that it will become plus 2 FeO. So here 3 CO, 2 CO. If you subtract, the leftover will be 1 CO. Carbon monoxide will be 1 only. And here iron, 2 iron are there, 1 iron is there. Sorry, 2 iron are there here in the third equation also, 2 iron, so that both are equally compensated. 2 iron we can cancel out, and 3 CO2, 2 CO2, the balance will be 1 CO2, so CO2 will be there. Fe2O3 plus CO gives rise to 2 FeO plus CO2. This is the subtraction of equation 3 from 1. At the same time, we have to subtract its delta H also. Minus 33 kilojoules can be subtracted from minus 26.8 kilojoules. The leftover will be, if both are subtracted, minus into minus, it will become plus. Larger value is having plus term, so that whatever subtraction value, that is 6.2, will be accorded with the plus symbol only. So entire equation can be retrieved, and the final delta H of enthalpy for this reaction will be, here you can see delta H is equal to minus 26.8 minus into minus 33. Minus into minus, it will be plus only. So here 33 minus 26.8, 6.2. But larger value is containing plus term, so that we have to put a plus over here. Plus 6.2 kilojoules. For question number 4, option number C will be the correct answer. Let's move on to question number 5. Here, so many kind of statements are provided regarding that what periodic table. From this, we have to get which are the correct options, correct centrality of the concept we have to find out. The order of first ionization enthalpy of first 3 elements of third period are provided: magnesium, aluminum, sodium. So before entering into third period, first of all, generality about ionization enthalpy trends we have to know. From top to bottom, ionization enthalpy gradually decreases. From left to right in the period, ionization enthalpy gradually increases. In accordance with that, sodium is the main group element 1, magnesium is the main group element 2, aluminum is the main group element 3. So we have to go for aluminum is the highest, next magnesium, next sodium. But in the practical sense, magnesium will come over aluminum. That is because magnesium is having NS2 NP2 is the valency shell configuration, which is completely filled. Always completely filled and half filled are more stable, requires higher energy for the removal of electron. That's the reason why magnesium will be accorded with the higher ionization enthalpy, and the next will be aluminum, and the obviously least will be for sodium, being it is the first main group element, S block. Fine. So this is the right order only. Let's go with the option number 2. The element with the electronegativity 3.5 is the chlorine. Chlorine electronegativity as per the Mulliken scale is 3 only. 3.5 is not correct representation. The order of sizes of ions, magnesium plus 2, sodium plus F minus, O minus 2 will be. So if you see all these, 2 of the ions are electronegative, 2 of the ions are electropositive. Here, one thing we have to remember in order to give the order of this kind of ions, always negative ions are the larger in size, Positive ions are in the smaller in size. As the negative charge increases, size also increases. As the positive charge increases, size also decreases. So that's the reason why O minus 2 is of larger. F minus is the next level. Sodium positive will be the next, and the least is accorded for magnesium plus 2. This is the right order only. Option 3, whatever order given is absolutely correct. Let's move on to IUPAC name of the element with the atomic number 106 is borium. As per the IUPAC nomenclature, 1 denotes un, 0 denotes nil, and 6 denotes septium, like that. Borium is not right representation, so that 4 is also not correct one. So let's see how to answer this question, and this is also provided in Telugu. మూడో పీరియడ్ లోని మొదటి 3 మూలకాల ప్రథమ అయోనైజేషన్ ఎంథాల్పీ క్రమం మెగ్నీషియం, అల్యూమినియం, సోడియం. ఇది కరెక్ట్ ఆన్సర్. రుణ విద్యుదాత్మకత 3.5 గల మూలకం క్లోరిన్. దిస్ ఇస్ రాంగ్ వన్. 3 రుణ విద్యుదాత్మకత, క్లోరిన్ యొక్క రుణ విద్యుదాత్మకత 3 మాత్రమే. అండ్ మెగ్నీషియం ప్లస్ 2 Na ప్లస్ F మైనస్ O మైనస్ 2 అయాన్ల సైజుల క్రమం మెగ్నీషియం ప్లస్ 2 less than, sodium plus less than, F minus less than, O minus 2. ఇది సరైన క్రమం. పరమాణు సంఖ్య 106 గల మూలకం IUPAC నామం బోరియం. సో ఈ IUPAC నామన్క్లేచర్ లో బోరియం అనే వర్డ్ రాదు. సో కాబట్టి ఆప్షన్ నెంబర్ 4 కూడా కరెక్ట్ కాబట్టి. Then let's see option 1 and 3 are the correct statements for this question number 5. Let's see how it is possible. If you see sodium, this is having 3s1 electron, magnesium is having 3s2, means completely filled, hence it is more stable. Aluminium with 3s2 3p1, it is not completely filled or half filled, hence its enthalpy is somewhat less, ionization enthalpy is somewhat less. Highest will be for magnesium, next ionization enthalpy for aluminium, next will be for sodium, right? So that is the right order. And next, so as per the Mulliken scale, chlorine electronegativity is 3 only. They are asking for 3.5. 3 is the correct answer. And next, if you see the sizes of all the ions, being positive charge, smallest is Mg plus 2, and the next level somewhat positive charge got decreased, Na place is still larger, F minus is the larger one, O minus 2 will be the largest one. This is about the radius of ions, that may be cation or anion of isoelectronic in nature. More the negative charge, greater the ionic radius. More the positive charge, lesser the ionic radius. Let's move on to last question of the session, sixth question of the session. Here 2 columns are provided, list 1 and list 2. Here molecules are there, their geometry to be depicted. Here shape of the molecule to be depicted. SnCl2 is called stannous chloride. Stannous chloride is given with the angular geometry. Next, NH3 is called NH3 actual geometry is tetrahedral. If you exclude that lone pair, trigonal pyramidal will be there. I3 minus is the linear one. SO3 sulfur trioxide is the trigonal planar. sp2 hybridization will be there. Let's see how to get their Lewis structure. So here జాబితా 1 జాబితా 2 ఉన్నాయి. అణువు లేదా అయాన్ తీసుకున్నాం, వాటి యొక్క ఆకృతి గురించి డిస్కస్ చేస్తున్నాం. SnCl2 కోణీయ ఆకృతిని కలిగి ఉంది. అమ్మోనియా త్రికోణ సూచ్యాకారాన్ని కలిగి ఉంటుంది. I3 మైనస్ రేఖీయంగా ఉంటుంది. SO3 త్రికోణ సమతల ఆకారాన్ని కలిగి ఉంటుంది. Right, let's see what will be this is the right representation of map the following, and here is the geometry of all 4 compounds provided over there. SnCl2 will be accorded like this, and you can see clearly it is the bent angular geometry, angular shape will be there. If you are taking ammonia, where lone pair of electrons if resided upon nitrogen, we can say trigonal pyramidal with the sp3 hybridization. And I3 minus is there, all the iodines are laying on the same line, hence we can say linear, and with the negative charge, hence it is the ion. SO3 is the sp2 hybridized compound with the trigonal planar geometry. This is the way we can answer, and all the kind of compounds are mapped with their shape of that molecule. So by this we successfully completed the entire session. of intermediate chemistry. Hope this session will be very much helpful for your serious preparation towards any entrance or competitive examination. Hence, I am requesting you to kindly like the channel, comment where you're actually interesting for and which part is very much helpful for your preparation, and fetching for your kind of what a weightage of your marks scoring. So that part you can mention over here, and share this channel with the aspirants whoever preparing for the competitive exams like that. Subscribe the channel in order to get more such kind of videos in the future entrance or competitive chemistry world. Thank you very much for patient listening of this kind of session. Thank you one and all.